Hi, my name is Chen. I am from Stanford University. I'm a second-year PhD student in Management Science and Engineering. And I'm part of a group on campus called the Stanford Sports Analytics Club. Today I'm going to be talking about basically looking into the question of whether or not we can use information about collegiate basketball offensive systems to help project and predict whether or not certain college players who are draft prospects in the NBA may turn out to be star players or bust players. So I'll step through kind of the framework that we decided on to go through with this analysis, which consists of a regression, a clustering, which led to some insights about different play types and play type distributions that really drove the brunt of our insight into this question. So first, our framework. We wanted to be able to evaluate players on a common metric, a common single metric that encapsulates some sense of player quality. And so if you're familiar with basketball analytics, you might know about value over replacement player, John Hollinger's PER, and win shares, and other assorted kind of catch-all metrics. So we'll look into each of those as to their suitability for our analysis. And then we also then wanted to come up with a sense of, okay, so once we've decided on what metric we want to use, then how do we use that to define whether a player is a star or a bust? So this is kind of a chart. I've just kind of like clicked through these. Whoops. Okay, so basically we started out with just information on the draft position, and we know that for all the metrics that we care about that we can easily get those. So then between draft position and the regression analysis, we can, independent of their collegiate offensive system, we can come up with some kind of projection. Then if we are able to come up with some description or labeling of collegiate offenses into clusters or groups that are descriptive clusters, then we can now use that information to say we're going to make a projection as to a player's NBA performance based on, in part, the collegiate offense they come from. So now kind of stepping back into metric selection. So we took data for drafted players from 2006 to 2015. And so on the horizontal axis, you see the draft position, so from the first pick through the 60th pick. And in this case, this is John Hollinger's PER and scatter plot, and then try to find the best fit curve. So you see here R squared 0.755. The next one, value over replacement player, does a little bit better, 0.784. The one we ended up choosing is win shares. So you see this R squared 0.923, and just kind of visually, it seems to make quite a bit of sense. So
how many years of data are you talking about?
2006 through 2015. So then now with this best fit curve, we have some semblance of an expectation of, if you have the 5th draft pick, then you can expect, and sorry, one more thing I should mention is the vertical axis is for over the first 4 seasons of that player's career. And this was just somewhat arbitrary on our part, but we kind of decided that, if a player is going to be a star or a bust, you'll pretty much know within the first 4 seasons.
So is that 10 years of #1 draft picks? So 2006 to 2015?
Yes, I believe so. Yes. Yeah, so the average across those 4. Yeah. So now we have some semblance of expectation. And so when I go into kind of how we define stars and busts, it'll be with respect to some measure of their win share performance. In particular, so here are the stars and busts that we devised. If you're familiar with basketball, probably a lot of these stars are very familiar, and even some of the busts as well. So here was our criteria. We wanted some measure by which approximately 5 to 10% of the league would be categorized each as stars and busts. And so on the star player side, we decided that would be measured by total win shares. And so 20 win shares was our cutoff, and so you see there are all those players are 20 win shares or above over their first 4 seasons. The rationale being that you don't really care when you're calling someone a star player, you don't really care what their expectation was based on their draft position. Manu Ginobili is no more of a star compared to some other player because he was drafted in 50th pick or somewhere around there, right? On the other hand, for busts, that definition is relative to their draft position. You expect a lot more out of a first or second pick. If a 60th pick doesn't pan out in the league, you don't really consider that to be a disappointment, right? So you'll see here that these players are sorted by net win shares, which is basically you take their expectation and you subtract off, or rather, how many win shares they actually realized over the first 4 seasons. You subtract off the expectation over those first 4 seasons based on your draft position. And so our cutoff here was basically 6 win shares below their expectation or more below that. So some of these names are probably familiar. Notably, Greg Oden was in the news a few days ago. He said, he basically said, I am the biggest NBA draft bust in league history, and so, accordingly, there he is. Okay, so our first pass was basically to try to do what we consider to be the simplest analysis we could do. Can we, just using the stats that we already have about these college players, come up with some prediction about how well they'll do in the NBA? And so we, in our regression as features or covariates, we included basically a hodgepodge of advanced metrics that try to isolate, true measures of a player's offensive and defensive skills. So instead of just straight up field goal percentage, I think we used effective field goal percentage that waits for the three-pointer being worth 3 points, et cetera, or true shooting, those kinds of things, as opposed to just your standard box score stats that are, points and rebounds and such. So here's our result, and so when we did this, the draft hadn't yet happened. So this is for the draft that just happened, and at the time, this was the most recent Chad Ford big board of the players that he thought would go in the first round. And so you see that a lot of these players, so you'll see this expectation of win shares, and this is just based on all the sabermetrics accumulated over their collegiate careers. But then we also included these 95% confidence intervals. And as you'll notice there, these ranges are pretty wide, right? So for almost every player, the span of the 95% confidence interval spans what we would have defined as a bust and what we would have defined as a star player. So effectively not very useful, right? And so we basically used this analysis to reaffirm, what a lot of people who follow basketball already know, which is that you can't predict a college player's performance just based on, in the NBA, just based on measures of their collegiate in-game performance. So then we wanted to come up with a smarter way to incorporate some sense of the offensive system that these players come from to help project. There's one statement in particular that I've heard a lot from basketball pundits that says players that come from 4-out, 1-in motion offenses tend to do worse in the NBA because that offensive system makes players look better than they actually are because it's a lot of scheme-based advantages as opposed to individual athleticism, individual playmaking. So we wanted to basically find a way to quantify, is that true, is it not? So we had access to data from a company called Synergy Sports. They have college students hand code literally every basketball play that happens in both college D1 and NBA. And so this is college classes. I guess it's kind of blurry, but they hand code for what kind of offensive play it was that resulted in the end of a possession. So that can be either a turnover, or scoring the ball. So you see pick and roll. Roll man means that there was a pick and roll that was run and the roll man ended the possession. So presumably the ball handler dishes it to the guy setting the pick, and either they shoot the ball and score or miss, or they turn the ball over. Similarly, there's ISO, transition, all kind of standard kinds of basketball plays. And so basically what we were able to do is we scraped all of that data for all of the teams that sent players to the draft, and we clustered teams based on this kind of, you can think of each team has a vector probability distribution over these play types that describes what their offense is like. A certain team might use ISO 15% of the time and spot up 10% of the time, and then and so on and so on, and a different team will have a different probability distribution. So, and then we can use k-means clustering to group them into clusters. We found just by looking at the results that 8 clusters seem to be the right amount. So you see like each of these is 8, or each of these graphs has 8 bars, and each of them describes the percentage of times that offenses in those clusters use that particular play type. So you can see that, like, for example, cluster 5, relative to the others, doesn't really use pick and roll, doesn't use off-screen, doesn't use ISO. What do they really actually emphasize? It looks like they emphasize a lot of spot-up shooting and a lot of cut plays, right? So this is like your prototypical 4-out 1-in motion offense, right? Okay, so then once we have that, I should mention that this is college and season. So like 09 Duke is different from 2010 Duke, is different from 2011 Duke, etc. So once we have this clustering, then we know, obviously, which offenses fall in which clusters. And so since we know which offenses fall in which clusters, we also know which players got drafted out of those clusters. So here we kind of, we put in some, what we thought were representative offenses from those clusters, and then the corresponding stars and busts that came out of that grouping. So the first one, balanced, and UF11, Chandler Parsons. Chandler Parsons, if you follow basketball, he kind of accords with your intuition of like all-around small forward. The 2 clusters that I really like to look at are these ones that emphasize ISO, 6 and 7. So you see the star players are Kevin Durant and Steph Curry, and of course, like both in the NBA and in college, they were extremely dominant players, and so it makes sense that their coach's offensive strategy was, well, let's just give KD the ball, right, and let him do whatever he wants. But similarly, Adam Morrison and Austin Rivers, who we classified as busts in this model, were similarly very talented and were performed very well in college, and somehow those skills didn't translate as well into the NBA. Okay, so then on the right side of this chart, we have 3 numbers. One is, the leftmost is the total number of players that were drafted out of each cluster. And then next after that is the number of stars, and the number of busts, and then the net number of win shares per player. So one thing you see is that some clusters are represented more than others. And some clusters perform better in terms of net win shares per player better than others. So that's kind of our first insight is, it looks like the ones that emphasize ISO are, in general, better for net win shares per player. And if we think back to what I was saying, like about 4-out 1-in motion offenses being really bad for players, like, oh, maybe that's true, -2, right? Whereas offenses that emphasize ISO might have players that are just really athletically gifted and really just in general like overpowering individual ability, and so they might tend to do better in the NBA, where all of a sudden that is the new norm, is that phenomenal athleticism. Okay, so this is kind of a tangential question, but nonetheless really important that we wanted to be able to answer. You also hear anecdotally a lot of NBA pundits say, oh, this player is going to do really well with this team, is a good fit because he came from an offense that plays similarly to this NBA coach's offenses. And we wanted to be able to definitively say, is that a valid statement to make or not? And so with each of these offenses characterized as this 11-dimensional vector, probability distribution over play types, then we can define their cosine similarity between, for example, a draft prospect's college team and the NBA team they ended up in. And so, hypothetically, if that NBA pundit statement were true, then the lower the vector distance, the higher their win shares above expected should be, right? And instead, what we found is this scatter shows that there's basically no relationship between how similar college and NBA offenses are and how well those players do relative to the expectation of their draft position. So that was kind of an important and cool statement that we thought that we debunked.
Plus our square being similar, right?
Right, yeah, exactly, precisely. And just visually, it doesn't really, you don't see much of a trend. Okay, so the last piece is play type homogeneity. We wanted to answer another question, which was, do star players at each position tend to come from similar offenses? And do bust players from each position tend to come from similar offenses? So again, we have this sense of Euclidean distance between these vectors, and you see kind of across the board that stars do tend to come from more similar offenses than busts. The last one that I'll get into is kind of play type distributions. And this is probably the brunt of our contribution. Basically, once we know which offenses produce star point guards and which offenses produce bust point guards, then we can look at the aggregate play type distributions for those offenses that produce those stars and busts, and look at how they deviate from the typical college offenses. So you'll see the 11 play types horizontally, and then the deviation from collegiate average. And so ideally, the most interpretable result would be one where you see a large deviation so red is for stars, blue is for busts. You want to see a large deviation in opposite directions for a given play type, right? And that would basically allow you to make some statement that says, for point guards, for example, the proportion of transition plays that a collegiate offense plays is a good differentiator or a good predictor of whether or not a collegiate player might be a star or a bust. So in this case, it kind of makes sense. If you're a point guard that really doesn't transition, then it may be because your point guard is not a great passer, right? Right. So it emphasizes transition and pick and roll passing, and that kind of accords with our intuition of the skill sets that are required of NBA point guards. Can I step through quickly for each position? Here, for shooting guards, you see not much deviation for stars, so you can't really say much about where star shooting guards come from, but you see big ones for busts. So they tend to really emphasize post-up, so it means that maybe your wing player isn't the dominant ball handler and scorer, you instead dump it down to your big man. Yeah, okay, and this is probably our best one of the positional charts. You see in almost every position, what I talked about exactly before, so large deviations in opposite directions. So you see the proportions of spot-up plays, transition plays, and ISO plays are really good differentiators of whether or not a small forward you're looking at may be a star or a bust. Step through more. I guess, yeah, these are not so interesting. This one has an interesting conclusion. Star centers tend to come from teams that transition often. And you think, that's kind of weird. Centers usually aren't running the floor that fast. They're not really involved in transition plays. But, so here's our intuition and explanation behind it, is a star center typically has really good defensive skills and can spark a transition play by blocking a shot, being in a passing lane, creating a turnover, and if additionally they have good outlet passing, then all of a sudden, boom, you're in transition. And so that's what we've come up with explanation for that. So results and conclusions, we debunked a few punditry statements about, what does collegiate offense mean in terms of NBA performance. We did that through K-means clustering and mapping to star and bust players via their win share expectations. And I want to show you one appendix slide that I think is really cool. Sorry, I'm going to go this way. So another thing that you hear pundits say a lot is, well, this guy has great pedigree. He went to Duke. He went to Kentucky, right? And so we defined top coaches and not top coaches by how many players they sent to the NBA over the course of their career. And what we found is the effect of a top coach is actually is not good. So we tend to overvalue players that come from top schools. And so yeah, so that's kind of interesting. And the last thing that's kind of interesting also is kind of according with our intuition, high school players are very high variance, and international players very frequently don't pan out. So that's the last piece. I guess at this point I will retreat back to the question slide, and I'm happy to take your questions.
We definitely have time for a couple.
I'll throw one at you, maybe, I'm sorry. It might have been a misunderstanding on my part, but the cluster slide, the point made in the cluster slide where I pointed out that it had a very small R2.
Yeah.
Was the point on this one completely dissimilar to the point on the next one?
Sorry, on this one?
No, there was, hang on a minute.
So basically here we were trying to say, if your college offense is more similar to your NBA offense,
Right.
does that mean that you get some bonus, right? So even if you're drafted 5th, you're expected to contribute X win shares over your first 4 seasons to your team. If your offense from college is more similar to the one that you joined in the NBA, does that make you even better than compared to your expectations?
And the answer to that question was no.
Right, exactly. Because, so 0 here is you performed exactly as expected based on your draft position, right? And so you see no discernible trend across how similar the offenses are to each other.
Right, and the slide that came immediately after this,
Mm-hmm.
I thought you said that this like star average showed that was true.
Oh, no, so this is, do they come from offenses that are more similar to each other? Collegiate offenses that are more similar to each other, not collegiate offenses
Oh,
being
okay,
similar to the
not
NBA.
similar to the NBA.
Yeah,
Okay.
so basically saying that you can look for archetypes of collegiate offenses
Okay,
to
okay.
search for star players.
All right, that was
Correct.
my misunderstanding.
Yeah, sure.
Thanks.
So, and there was an assumption of stability in the offenses. So, for instance, in college, so if the
Mhm.
coaching change, which is rare but happens,
Sure.
and the star is still there, you know,
Mhm.
potentially the style of play would change. But
Sure.
but
Oh,
you
yeah. So
only had-
there's one part that I guess left unspoken. We mapped every player to only the last season that they spent in college.
Okay.
Yeah. Thinking that that is the most indicative portion that at least scouts and GMs will use to determine
Gotcha.
where a player gets drafted.
Okay.
Yeah.
Which is a valid assumption for Kentucky, right?
Sure.